Is the intro is done?
Hi.
Hi sir, good afternoon. Everyone, good afternoon.
It's already 1 o'clock. Why we don't study? Hi.
Oh, hello everyone.
Hello.
Hey, happy Friday for everyone. I hope everyone is healthy and in good shape. Are you all excited to start with the new school year?
Yes, but actually after going to a party.
Yes.
Today will be the last explorers we have, I think. And today we will talk about chemistry. We already did physics with the planets and the stars. Last week we did biology with the leaves and the plants and how they grow. And today we will do a little bit of chemistry. We will not do the boring chemistry with equations. No. Today I will show you stuff which you can do at home. Okay, everyone? Are you ready? No. There's a cool button here. Look at this. I made a nice thing again. No. Today, Explorers number 3, a funny look at chemistry. Chemistry for at home. Now, actually, everything in our universe is chemistry. Everything that we do, everything that we see around us, it's all chemistry. Everything around us works together or against each other. So everything in the universe is connected with each other. We are connected to a table. We are connected to the plants, the trees. Everything has a certain connection. And today I'm going to take you through some funny parts of chemistry. It's not all equation. Now, chemistry, many people call this the subject of reactions and explosions. But I like to call this the subject of change, changing of energy, changing of material, changing of place. And today we will take a look at how things can change in a really short while. Now, what is chemistry? Chemistry are the reactions and changes in materials. Why is a gas a gas? Why is liquid liquid? Why can we move it around? What happens when it freezes? We learn all of this in chemistry. Please don't draw on the board. Now, why should we study chemistry? For some subjects, for some jobs you want to have when you're older, like working in a laboratory or working with cleaning materials, you need to do chemistry. If we clean something, it's actually the reaction between two things. Ever tried to clean a pan without soap and try to clean it with soap? You see that the soap will react with the fat. It will dissolve it. It makes things a lot easier to clean. So we use it in the kitchen when we cook. We use it when we clean something. We even use it when we breathe. We take in oxygen and our body uses sugars and energy and it turns it into carbon dioxide and water vapor. We do chemistry in our stomach. Food goes in, there are acids in our stomach which burn the food a little bit. Energy will go out of it. We become warm with the energy, we use the energy, and The things which do not dissolve in our body, we dump them a day later at the toilet. This is nice brown color. If you ever do chemistry with me,
Chemistry.
I can show you that when we
Chemistry.
put into an acid, it will turn brown. And it's the same color as when we go to the toilet. Now, is chemistry dangerous? It depends on what you do. If you work with really strong chemicals, liquid chemicals and gases, yes, it's dangerous. The gases and the liquids, they can move with each other. So they mix really easy. Solids, on the other hand, they are stationary. They don't move. They don't do anything. So solids are quite safe to work with. That's why you see when you're in our chemistry lab at school that most of the things are solid. We only have a couple of liquids and they're all in. Now, when we do chemistry, we always need to make sure that we and the people around us are safe. We need to wear gloves, glasses, something to protect our mouth. There are gases coming free. We need to wear our white lab coat. If you do chemistry at your home, don't do it inside in your bedroom. You might turn your bedroom into a blazing fire. This is not handy to do. Try to do things outside. There might be a gas escaping somewhere and you might faint because of the gas. And no one knows that you fainted because you're in your bedroom. No, when you do chemistry, do it or in the lab where we have a safe environment. There's not many things which can lit on fire. We can still put things on fire, it's fun. Or do things outside where there is a wind, where there are things which help to get all the dangerous gases away. Now, is chemistry fun? It depends on you. Do you like chemistry? Do you like to see things explode and things react with each other, bubbles and things which can float like a gas or things which can go down? The change of a voice. We can have a really high voice or a really low voice with certain chemicals. Now, chemistry is also a lot of puzzling. Are you good in puzzling? I have 4 bananas and 2 apples. What happens if I have 8 bananas? I will get 4. Everything in chemistry is in the ratios, the same ratios that you use with fractions. Are you good with fractions? Then chemistry is something for you. Are you horrible with fractions and mathematics is not your thing? Then chemistry is a lot harder. But chemistry is a puzzle to make things react or to not make things react. Sometimes we don't want things to react. Let's see, I'm sitting at my PC here. Do I want my PC to be on fire? No. So, what is inside of the PC? A lot of rubber. And rubber, it isolates the energy from electricity. So it doesn't become warm. It doesn't fry my PC and turn it into a black cloud of smoke. So, with chemistry, we can do 2 things: no reaction or reaction. And the reaction is fun. So, today we're going to take a look at a couple of experiments which we can do at home, outside, safely, with your gloves, with your goggles, and a coat and a mouthpiece. I don't want you to get sick. Okay, let's take a look. Now, maybe you know this one, the Coca-Cola versus Mentos challenge. Now,
Wow.
Of course.
I like Coca-Cola and Mentos.
Coca-Cola the water Coca-Cola gonna be out from
yeah.
the bottle.
Now, what do we need for this? We need Coca-Cola.
Mentos.
The nicest is a big bottle, so we have more of a reaction. And we need to have
Mentos.
Mentos. Now, what is happening inside? Can you please not draw on my screen? Thank you. Now, what is happening? If we have a glass of Coca-Cola and we put a Mentos inside, it just bubbles a little bit. But if the shape is in a bubble, all the energy needs to go to a really tiny space. So it will shoot out everywhere. Now, what's happening inside? The sugars are reacting with the cola and they make a lot of bubbles. So let's take a look at what happens here. Here we have a cola bottle. The man or the woman, I think it's a man, is opening up the cola bottle and will put a Mentos inside. Now, as you can see, when the first Mentos is falling in, already bubbles are escaping a little bit. The Mentos will start to react and it starts to expand
Oh no.
everywhere. And we got a lot of cola everywhere. So don't do this in your home because everything will be covered in cola. Can we still drink the cola? Yes. There's actually nothing wrong with the cola. But all the bubbles, all the soda is out.
Why? Why Coca-Cola, Mentos, give inside can be exposed?
Now, what happens inside? We have a sugar, and inside the cola is a lot of nitric acids. They react a little bit with each other. You might know if
Can we see even it already has a bubble?
you might know if you drink a lot of cola that your teeth will go away. You might know that when you eat a Mentos, it really quickly gives you a fresh breath. It is really easy to lose the energy. So if we throw this inside of the cola in a really small period of time, it starts to do lots of stuff. It starts to bubble like crazy. Now, if it bubbles a little bit, it will just come out at the top. But it bubbles so much that there's no more space left in the bottle. So everything shoots out like a little cannon. Well, let's take a look at it again. It's nice in slow motion. Now, there's no more room in the bottle, so the bubbles want to go out. The bubbles are bigger than a drop of cola, so they take more space. It needs to go somewhere. So the only place where it can go is out of the bottle. It's like when you step on the side of a bottle. You can see all the water or the drink coming out as well because it has no other place to go. And for the cola, exactly the same. Now, how can we make this look cooler? What can we do to make this even more fun? Now, of course, we can have more cola. Let's take a big gallon, which we use for our drinking water. Let's fill it with a bunch of cola. Let's make the cap a little bit smaller. Let's put some Mentos inside. What will happen? And it will become much higher. There is more cola, so there is more bubbles to be made. And we have a bigger reaction because we have more things. Okay, I see some questions. Yes, you are allowed to drink. You can still drink it, yes.
What? If we drink too much?
Too much cola is not good for you. Cola dissolves your teeth. They will become black. You get holes in your teeth, and after a while, you cannot even eat anymore. All your teeth will be gone. But cola is not so good for your teeth. It dissolves things which we call carbonates. Carbonates are in our bones, and they are also in our teeth. So if we drink too much cola, it will dissolve. Our teeth will get holes in it, and eventually they will fall out.
Why?
They react with each other. In cola is a type of acid, and our teeth are made of carbonate. It's like a magnet. One is with plus and the other is with minus. They attract, they are friends. But if we have both on the plus, they want to fight with each other. That happens in here exactly the same. So when you do this at home, try to do it outside. Otherwise, it shoots up, it's on the ceiling, there will be ants everywhere. Now, how can we make it look cooler? We can put some soap in it, so the bubbles will not go away, but the bubbles will stay there for a while. We put a little bit of milk in it, it will become a thick foam.
If we take the Coca-Cola and we shake it.
Yeah, exactly the same is happening when you shake it. But it happens more when we do the Mentos. Now, what can we do as well?
It's gonna explode.
Now, it will not explode because the bottle is quite strong. It will not explode inside the bottle. The bottle might have a rupture, a little bit of a opening, and it will shoot out. But it will not explode like a bomb. It's not strong enough for that. Now, the other thing we can do is we can put some food coloring inside. A little bit of red or a little bit of green, and it will get a different color. Why do we put the closer cola will be? What happens if we close it? Close the lid. Not close the closer, close the lid. Now, if you're quick enough, the bottle will
do nothing.
build up pressure inside. It's like a balloon. Now, there might be a little weak spot on the outside, and there might be a little bit of a tear inside. And what happens? The cola will come out from that little spot. The smaller the spot is, the further away your cola will shoot. So you can do this as well with making a little hole in the lid. Quickly close it, and you can hold it in your hand and you can shoot at people. But everyone will be dirty. It's better to stay a little bit away from it. If the bottle opens up, you're all covered in cola, it's sticky and yucky. Okay, let's take a look at the next one. Now, here we have the elephant toothpaste. What is elephant toothpaste? What do we do? Now, the ingredients are hydrogen peroxide. Someone who works at a barber shop and changes the colors of people's hair, they use hydrogen peroxide. It bleaches your hair. Now, this is dangerous. If you get it on your hand, it will bite a little bit. So be sure that your parents do this one and not you. We need to have yeast which we use in bread as well. We'll expand a little bit.
What the useful of elephant toothpaste?
I will try to explain. It is just a name, yeah? It's a reaction. An elephant cannot use this, don't worry. It's just the name of the product. Now, we need to use yeast. And what will yeast do? Yeast is like a turbo which you put in your car. It goes a lot quicker. We call this a catalyzer. It makes the reaction go a lot faster. It's like I'm asking grade one to do homework, and they're all like, "Yeah, I don't want to." Then I tell them, "If you do your homework, we're gonna watch a funny movie." Wow! And all of grade one will work really hard and do their homework. A catalyzer make things go faster. Another thing which we need to put inside is soap. Soap makes the cool bubbles. And food coloring. We can put in one color, or two, or three, or four, and we get a whole rainbow of colors. Now, I'll show you what happens in the video. Please don't be scared. Now, they make a really big reaction here. And there's a lot of elephant toothpaste. Look at this. It expands so quickly and it goes everywhere. Now, you can see everyone is wearing glasses because it's not really safe. They're wearing suits because it's still a chemical.
So we should learn if we made that.
You should run
fast.
away really quickly when you do this. You can see smoke is coming off as well because it's not a healthy thing. It becomes warm and it goes everywhere.
So what if when the export the elephant toothpaste uh, um we um kena without cheat,
We need to. Oh, when you touch it, it will bite on your fingers.
but if
Not
we
really nice.
swim there because the export is too fast and we don't landing so fast.
If you get hit by it, you need to put your hand under the water to clean it. Yeah. But here they make a really big explosion. And normally, if you do this at
What
home, it
happened
will look
when
same
we
as the
the
Coca-Cola.
elephant toothpaste?
I
We
have a
right
question.
Sorry, not two at the same time. That doesn't work.
and
Who has
we
a question first?
and
Like, here we dive.
and we fall and we touch it because land so fast we can fall.
Yeah, you can fall, but you will not die. It will be irritating on your skin, like you've been in the sun for too long. It will hurt a little bit. Huh? So it's not nice to do. As you can see, all the people here as well, all of them are wearing suits to keep them safe. And we need to wear safe clothing as well. With chemistry, things can be really dangerous. Look at what they're wearing: a suit, gloves, goggles for their eyes, and even a thing on their head. Look at how safe they are working. We also need to work really safe if we do this. So if you do this, don't do it with 1,000 liter like they do here. That's a lot. Let's do it with a little cup, maybe half a cup, and you can see how big it will become. But don't use too much. Now let's look at it again. So what is happening here? They put a lot of stuff here and a lot of stuff on the top. They throw the yeast into the hydrogen peroxide, and there's already soap inside. Now they will react with each other, and what do they do? It is evaporating, it becomes a gas. But because we put soap in it, all the gas will be in little bubbles.
Can
And these
we watch
bubbles
it
will
again?
break so quickly.
Can we
Yes,
watch?
what's your question?
Can we watch again?
Yeah. I'm
What
gonna play
is
it
it?
again. I'm just explaining in what's happening. So here they mix it, everything comes in, and you can see that they want to run away. Now it comes out a little bit, and then it expands like you step on a nest of ants. It goes everywhere. Looks cool, right?
That's super cool.
You
Until it
can
falls.
see. Well,
It's like an volcano.
as you can see, there is gas coming out of it. It means that it's really warm. So if you do this at home, wear your gloves and wear a cloth which can become a little bit dirty. Don't wear your nicest clothes for this. It will take all of the color out of your clothes as well. Now, you might look at this girl. This girl isn't doing things well. If you do things in chemistry, you need to be sure that your hair is tucked away. What if she was working with fire and her hair is everywhere? And her hair will be gone. Now let's take a look at it again. It turns from green to blue and it fills the entire garden in just a couple of seconds. So don't do this inside of your home, and if you do it, take a little bit to see what it does. The more you take, the bigger the reaction will be.
What if
Okay,
it's too
question.
much and it burns out the world?
Sorry, what
How
did you
much
say?
until it cover all the world? Is it
No, there is not enough to cover the entire world. Don't worry.
Nah, kan we can make so much, so big, and we tumpahin just uh, fall, and we don't know it, and it boom, and
There is not
cover
enough.
the world.
There is not enough to cover the entire world. Don't worry. Okay. It looks like a full. Now, can we die if we touch the elephant toothpaste? Now, I would not swim in it if I were you. But it will not directly kill you or anything. It might hurt your skin a little bit. It looks like a volcano. Yeah, if you raise your hand, I cannot see it because I'm in the other screen here. Okay, now, I'm eating candy, by the way. What can we do to make it look cooler? Now, what we do here is you might see that I put food coloring inside of it. And it gives nice colors. It goes from deep green to light green to mint yellow in a really short time. Do you see it changes the color? Now we can put a whole rainbow of colors inside. If you do this in a little bottle, you can put 3 or 4 colors on the side of the bottle, and you will have a beautiful spray of colors coming out. Other things you can do to make this nicer is to make more. The more you have, the bigger the reaction there will be. But if you see here, this is already really dangerous. How much they are using here, that's not as good as it is. But it looks really cool. You can see how quickly this is just as big as your home. They have only a thing which is just as big as a table, and in a short while it will become just as big as an entire home. Look at how big it is here already. It's already bigger than a home.
Sir, how about that human in black jacket?
The black one. Ah, take a look, yeah. That one can just get out of the spot.
How about that one?
Yeah, he's still safe, but he ran the wrong way. Everyone is safe after this one, so don't worry. But you can see after a while that things will fly away. They will go into the air, and look at this. They will rise up, they go into the air, and they might fly far away. So you're using chemicals here, don't use too much chemicals. It will be everywhere. Don't do this on the grass, all your grass will die. Do it outside on the street, on a safe place, not next to a car or something, not close to animals. It is still a chemical that you use. Now, yeast is something which we normally use as well in bread, water as well. Food coloring will not damage as much. The soap is not really good if you ever try to eat a spoon of soap. It's not really nice. But the hydrogen peroxide is a lot more dangerous. It will not kill you, but it's not nice for your skin. Now, let's take a look at the next one. Oh, a question. Let's see. Double the amount of everything. Yes, Anya. Then everything becomes 4 times as big because it's quadratic wise. So if you multiply everything by 2, it's 2 times 2, 4 times bigger. If you make it 6 times bigger, times 6 times 6, it's 36 times bigger. Now, please do not draw on my screen. Thank you. How do you get rid of the elephant toothpaste after the explosion? Good question. Time. This is soap, bubbles, and bubbles. If you sit in a bathtub, you might know after a while all the bubbles will pop and they're gone. So it needs to have a little bit of time. So you can spray some water on it to get the bubbles go away. You can throw sand on it. It will make the bubbles go away a little bit quicker as well. Okay, let's take a look at the next one. Now, matchsticks rockets. Now, with fire and with matchsticks, we can make small rockets. Don't do this inside of your home because you have things which are on fire, and I don't want your home to turn into a big fireball. That's not really nice. Now, the ingredients for this is matchsticks. Make a little bit of fire. What's inside a matchstick? It's a little bit of sulfur. The sulfur reacts with the air around us that gives the weird smell and it burns, it ignites. Aluminium foil, which you can buy at the shop. A lighter to make something warm. A paper clip, a needle, or a skewer, whatever you want. Now, I'm going to show you the video first. Advertisement. Now, what are they doing here? They have a little needle and some aluminum foil. They take a matchstick out. They put the matchstick next to the needle and they put the aluminum foil around it. So there's a little space left where the needle was. Now, why do we need this? The energy which comes from the fire needs to go somewhere. If it goes in the wrong direction, the energy goes to you and you burn your fingers. So you need to be sure that you are not getting hurt. So they leave a little bit of space on one side, then you know for sure that the fire will come out from that side. So you can keep yourself safe. Now they put the needle inside, they put the aluminum foil around it. You can make this with one matchstick, with two, or with five. Maybe you want to make 100 matchsticks and you make a little rocket, and the rocket will go into the air and you might hit someone, which is not so nice for the people. But you can make a rocket out of this. Now, they will pull the needle out. Yep. So there's a little bit of room left on one side. So it's not stuck. It doesn't mean that the aluminum cannot go anywhere and it will pop open like a small explosion. Now, we can make a whole box of this, like 10 or 15. It doesn't take that long to build. Now, what do we need to do next? We can put these ones on a skewer instead of a needle, and we keep the skewer in our hand. So there's a little bit of distance. Or like this person does, he just puts them on the table and shoots them away. Now, I rather use a skewer for this. So I have a long skewer and I have the little matchstick on the other side, and I can shoot it away. Now, what happens here? It becomes warm, and when it becomes warm, it wants to expand. It wants to go one direction. So the fire goes in one direction, and the matchstick will go into another direction. Now, let's take a look at it again, yeah? So the fire goes into the direction of the man, a little bit of fire, and the energy and the material will go to the other way, and it will shoot it away. Now, this man is not working safe. He has no goggles. He has no normal lighter, a really small one. Now, here you can see on the bottom that gas is on fire. gases burn. You can see a nice flame going through it. So this one didn't work as well. Now here he works a little bit safer. So what happens? It starts to ignite, it starts to become warm, and it wants to go somewhere. So energy will go one way and the material will go the other way. Now, what is happening here? Heat expands air. Maybe if you have a balloon and you blow the balloon up and you let it go on one side, you can see that the expanding air is pushing the balloon everywhere and it will fly around. This happens exactly the same here as well. The air is expanding and it brings energy to one side, and to the other side will be the reaction, the fire. How can we make this cooler? You can put them in a pencil. Oh, I don't have the pencil here. You can put them in a pencil and shoot them from a pencil. You can make 2, 3, maybe 5, maybe 15 of these little matchsticks, and you can shoot it a little bit further away. You can make it into a little rocket, make a shape around it with some fins on it, and it can shoot away like a little rocket. But be careful with this, you are playing with fire. So if you do this outside, wear your glasses so you can't shoot yourself in the eyes. Wear gloves, not rubber gloves, they will melt on your hand when they become warm. Wear cotton gloves, they protect you much more. And be sure that you don't point it towards an animal or to someone else. You don't want anyone to get hurt. Let's go to the next one. Now, chemistry is not only fire and chemicals. Chemistry is also the things where we are made from, living things. Now, here we are making the rubber egg. A rubber egg, can you make an egg out of rubber? No. It works a little bit different, and I'll try to explain it to you. The ingredients for this are egg, vinegar, yeah, and some thyme. That's it. You don't need anything else. Now, I'll show you the video and then I'll explain you what is happening here. Wink! A rubber egg. You might see that the shell is gone. Now, what do? We place the egg inside of a jar. And we put vinegar inside of the jar. Now, the vinegar is an acid. Maybe you remember from the test earlier that acids and carbonates, they react with each other. Here, the carbonate is the shell of an egg. It's from the same material as our bones. And the acid is inside of the vinegar. Now, make sure that the egg is underwater. Underwater, under vinegar. Be sure that it's swimming and not halfway. Now, you might see some bubbles getting out of it. It's the acid in the vinegar reacting with the carbon of the shell, and it makes a little bit of gas. Now, you need to wait 1, 2, 3, 4, 5 days. You don't know. So you can make more of these and you can check what's the nicest time. So, the longer we wait, the better it will be. As you can see here, the eggshell is completely broken. And you can just peel it away a little bit. It's soft. It's like a cookie which has been outside and it becomes like, it's not crispy anymore. So you can clean it and you can see that the egg inside is still there. Well, we can drop it. We can see how bouncy it is. But how bouncy is it? Drop it from 10 centimeters? 15? 20? When will it explode? There's still an egg inside. Whoop. Yeah, it's still an egg. Now, what happens inside of the egg? What is going on here? Now, It is like you want to grab cookies from a cookie bar. The vinegar can go inside of the cookie bar, grab some cookies, but then it cannot get out anymore because it's too big. It is a membrane. It is a place which lets things through, but they do not come back. We call this osmosis. You'll learn this in grade 9 or 10. Don't worry about the word. Now, so what happens here, the vinegar goes inside, it reacts a little bit with the egg, it cooks it in a way because they are reacting with each other, but the vinegar cannot get back anymore. It has become bigger and it cannot go out through the same hole anymore. So what happens? We get a sort of a jelly outside. It can still break. If you smash it with a hammer, you have an egg everywhere. So, but what is fun on this is that you can peel an egg without ever it breaking. You don't have to cook it. You can if you want. Cook it first and then do it exactly the same. But we can do this with a raw egg. So you have a bouncy egg and you can use this as a water balloon. You can throw it somewhere and it'll pop open. Okay, a question. Can we eat? Chemically, yes, you will not die. The taste is horrible. You eat vinegar with a raw egg, you will get like you need to vomit. So if you cook it, it would be better, but it's still a vinegar with egg. It's disgusting, Jason. I wouldn't want to eat it, but you can. You will not die, but I think you'll vomit really quickly if you eat this. Now, can we make this even cooler? Yes, we can. If we boil the egg first, it means that the inside is harder. So it will not pop open like a normal egg, but it will still be solid and it will bounce a little bit more. We can take a bigger egg. Let's take an ostrich egg, this size. Cook it a little bit. Put it in vinegar for a week, maybe 2 weeks. We need a little bit more time because it's a thicker shell. And we have a nice bouncing ball, a bouncy egg. Now, you can do this without getting hurt. You can see that they are not wearing gloves. There's nothing wrong here. There are no dangerous chemicals inside. There is nothing which can harm you here. But if you eat it, yeah, it's not really nice. I wouldn't eat it if I were you. Now you might see that it gets nice and bouncy, but it can break as well. And the egg is still inside. Now you might see this little skin. That's what we call a membrane. But the egg is still exactly the same. Now let's take a look at it again. Yeah. Put it in vinegar. And the vinegar will make it react with the shell. The shell will get bubbles on it, and after a while, there is no more shell and it will not react anymore. Wait a while until everything in the shell is gone and you're sure you can peel it off. And then after a while, maybe with a little bit of water, you can peel all of the leftover away. And you can see that inside here, oh, let's put it back a little bit. You can see that inside here are already many pieces of the shell. They already dissolved and they let loose. They cannot be used anymore. The shell is normally to protect the egg. And now we take the protection away. Now we can peel it a little bit. And then you can try how strong is it. What happens if I squeeze a little bit? What happens if I squeeze a little bit more? When will it pop? So when we cook it before we do this, that means that the inside is not soft anymore. We can squeeze it quite hard. It might break, it might split open, but you don't have all this egg yolk everywhere. It's a lot cleaner in that way. So, how to make this cooler? How to make this more fun? A bigger egg, cook it so it's stronger, more eggs. Maybe you can make a game of this. You have 5 eggs, and one of them was raw, and people need to carry them around, and one of them will accidentally burst open because that's the weakest one. No questions on this. Wow. Who of you wants to try one of these things out at home? Who of you thinks like, oh, I want to build a little rocket? I'll close this one. Stop screen share. So, is everyone still there? Everyone's so quiet.
Yes, I'm still here, but I'm eating.
I'm eating too. I have candy.
Me too.
Yeah. Now, do you think that when you go to grade 7 and grade 8, when you have chemistry during science, do
Little
you
soup.
think we can do something like this here in the lab? Or will we do other things? Maybe you want to do this for your CH Makers class. You want to let something react with each other. How many kids in grade 10 do you think are taking chemistry? Are there many children who take chemistry or just a few? What do you think? My beard is getting bigger. Last year we had Vina who did chemistry, and I think only Vina. We didn't have many students for chemistry. Now, chemistry is not really a favorite subject of everyone because we need to learn all the elements. We need to learn their electricity compounds and values, and we need to learn all their weights. But that's about it. When we know how they react, how to make an egg, Darren. Now, Darren, we cannot make an egg. We are humans. Eggs come from chickens, Darren. A chicken, when a chicken, when a human makes a baby, we get a live baby which is going out. Yeah? Mama will scream like, ah, there's a baby coming out. Daddy will be like, oh no, we have a new baby. Now, eggs are made by feathered chickens, like birds. Also reptiles. Birds are family of the reptiles. They make eggs. The little baby is inside of the egg. And they need to breed it out. So actually an egg is a little baby chicken. When it's fertilized, there will be a little baby chicken inside. When it's not fertilized, we have an egg like you and me know it, the thing we can normally eat. So, when you have a rooster with your hens, with your female chickens, they might get fertilized and all the eggs will have little baby eggs inside, little baby chickens inside. If this is not the case, if they don't get fertilized, we get the eggs that we can eat. First cook them, by the way, that's better. Pakano, another one. You need a plastic bottle, gunpowder, matches, and a string. Yes, you can make a bomb out of that too. And it will explode, but it's really dangerous. There are many more ways to make bombs and smoke bombs. You know the little things that you use during New Year, making the stars? You look at it for 5 minutes. These things, we can put them inside of a little plastic tube. The plastic will start to become warm, but it's not warm enough to let it ignite. So what does it do? It makes a lot of black, yucky, polluting smoke. So if you don't like anyone, you can put it in their garden and there'll be smoke in their garden. People don't really like this. I used to do this when I was a kid. I used to make smoke bombs and other stuff. And during the last day of the year, we had a really big garden, and I like to blow up things. I had helium and other types of gas, and I would ignite them. I would make a big bomb. I would have a lot of benzene, and I would make things explode. And when I was like 14, 15, it was still small things like a microwave. And when I became older, the explosions became bigger and bigger, and then my mom didn't allow it anymore. But it's fun to do. Now, chemistry is in everything around us, everything that we see. Any more questions about chemistry? Candy, sugars. We still have a couple of minutes. Do you want to watch another cool chemistry video?
No, I do have a
Other
question.
videos again?
I do have a question.
Hey, Pa.
Yeah,
I have a question.
go ahead.
So, what is the difference between chemistry and physics?
Now, physics is looking at our world and putting everything in a formula. We use numbers to explain everything what is happening in the world. Chemistry is the reaction of the elements together. In a few ways, chemistry and physics have the same chapters in the book. Things about atoms, how electricity works with each other, and energy, how much energy do we get if we burn 1 gram of sugar. These things are the same in physics and chemistry. But chemistry goes more into combining elements, and physics goes more into structures, power, and energy, and what happens if I walk on the moon? Things like gravity. Chemistry looks at the electricity between atoms, between the smallest particles. And in physics, we look at the electricity which we use for our electronic devices. Where does it come from? How can we send electricity through a wire? How can we do something on one side of the world? We put that energy in a piece of copper wire and we can take it out at the other side of our planet. How does this work? This is what we do in physics. Well, physics is more into mathematics, and chemistry is more into biology. So chemistry is with living things, and physics is more static, more dead things. Okay?
Okay, I got it.
Any other questions?
I have.
But now I have question.
Yes.
Before the elephant toothpaste, the bubbles, what does the bubble carry inside of it? Or it's just bubbles?
Sorry, I didn't understand you well. The bubbles,
Yeah.
they're flying away.
Flying. What is inside of the bubble?
Inside of the bubbles is gas. What happens with hydrogen peroxide? Hydrogen peroxide wants to evaporate, wants to become a gas. Now, if we put soap inside it, the gas will be stuck in little soap bubbles. So the bubbles have hydrogen peroxide gas inside.
Okay, one more thing.
Yes?
What was that? The question I forgot. Maybe later. I'll just ask again.
Okay. Anyone else with a question? You want to watch the cool videos again? Wait up, yeah. Make this one smaller.
I remember my question. How big is the bubble?
Sorry, how?
How big is the bubble of the
Bubbles are just as big as soap bubbles. Some of them can be 1 or 2 centimeters. Some of them can be 5
Are they
centimeters.
big ones? Do they have big ones like this big?
Sorry, yeah, I need to look at your camera. How big? No, maximum probably like this. 2 or 3 centimeters. Yeah, not that big. But there are millions of them. But together, they're really big.
Can we do a bubble party using that bubbles?
Sorry, can we?
Can we have a bubble party with those bubbles?
Bubble flying like a bubble blower?
Yeah, like we have a bubble party and the bubbles go everywhere and we pop them.
Yeah, I would not do that with these bubbles. They will hurt your skin a little bit. It will start to irritate, like you have a burned skin. It's not really nice, and you will be totally white after a while. All of the color will dissolve into the chemical, so your hair will be orangey white. Your skin will be orangey white, and you're itchy everywhere. And it's really unpleasant. You cannot play.
And the rubber egg. I remember that the egg inside it become like wobbly.
Yeah, the egg is still inside, eh?
Yeah, but it's still wobbly when we crack it.
Yeah, it's still a little bit yucky.
Yeah.
Yeah. Okay, I want to show you another video. Share the screen. Let's make this one big. Everyone can see it, right?
Yes.
Yes. Now let's take a look at some chemical reactions. Cola and chlorine. Now chlorine is something which cleans stuff. Now this is dangerous. You can see all the steam coming out. Cesium is something which reacts with water like crazy. Look at this. It expands really quickly. Hoppa, like a little bomb underwater. Advertisements. Copper and iron sulfate. Now this looks really cool. This is what we call displacement. It starts to rust in a way. Can you please stop drawing on the screen? Everyone can see your beautiful drawings. Soap and milk and colors. This looks disgusting, but it's nice to see. Mercury is really dangerous. It's toxic. Now, this is what we call dragon feet or dragon teeth, and it starts to grow. It starts to make a structure. Wow, yeah, cool, huh? This is also a reaction. It looks like something is coming from a different dimension. It's coming out of the ground, like wow. Now, lithium and fire is really dangerous. You cannot do this at home. And it's gone. They react with oxygen together. What? Yeah. It will become smaller and smaller and smaller, and it will become a gas. It's gone. Now, lithium is quite dangerous. We don't use it here at school. But it looks cool. Yeah, some animals really do not like certain materials and they will react with it as well. Now, This one is already dead, but because of the electronic parts in our body, muscle starts to twitch a little bit. Like an octopus, yeah? But this is an octopus. This will make it grow back alive. Now, calcium and fire, we have this here at school. Looks really cool. It looks like there's a spider growing out somewhere.
Yeah, it's like a spider that is on fire.
Looks weird, eh? Like it's getting out of nowhere. No, actually, it is only ash.
Yeah, like that, like a spider, like that.
Looks cool, huh? Now, chemistry is in many different ways. Where can we get calcium? Well, giraffe calcium is in your bones. Yeah. Probably most of the hardware stores have a form of calcium. We also use it to make gypsum. Bye. So calcium is used in many other ways as well. Yeah, it looks cool, huh? So chemistry is more than just the chemicals, it's reaction with things. Things change. So maybe, hopefully, we can get more kids into studying chemistry. Now, it's 2 o'clock, everyone. The lesson is done for today. Each other at school again, hopefully. So I will be here. I will be still teaching grade 10. So I'm upstairs above. Maybe you know this classroom. It's above the swimming pool.
Thank you.
I will still be here. Hopefully, I will see you back again too. Thank you for joining the classes.
Thank
I hope you
Bye bye.
everyone.
Bye bye.
Thank you, everyone.